Number 19 says a satellite is in a circular orbit around the Earth at an altitude of 2.52 times 10 to the 6th meters. Find the period of the orbit. And there's a hint. It says modify Kepler's third law. T squared equals 4 pi squared over gm of the Sun times the radius cubed. So it is suitable for objects orbiting the Earth rather than the Sun. So modify Kepler's law so that it's suitable for objects orbiting the Earth rather than the Sun. The radius of the Earth is 6.38 times 10 to the 6th meters, and the mass of the Earth is 5.98 times 10 to the 24th kilograms. So it wants to know the hours, it wants to know the speed, and it wants to know the centripetal acceleration. So here's what we have to do. T is the period of orbit. So T is the time for one orbit. Time for one orbit. And G is our gravitational constant. M of x is the mass of whatever the massive object is that we're speaking of. So it's orbiting the Earth. So this is going to be the mass of the Earth. And R is the distance from the orbiting object to the very center of the Earth. So we call this area the height, and this is the Earth's radius. So you got to add those together to get R. So let's go ahead and define some things. So the radius of the Earth was 6,380,000 meters. The height of the orbit above the Earth was 2,520,000 meters, and so the total radius, which is going to be these two added together, the radius is going to be 890 or 8 million. I'll keep screwing this up. 8,900,000 meters, and then the gravitational constant again is 6.673 times 10 to the negative 11th. And again, if this is not actually the right number, it's getting me the right answer, so I'm continuing to use it. So, and then the mass of the Earth is 5.98 times 10 to the 24th. And so I can take the equation here. So 4 times pi squared equals 39.47842. 4 times pi squared, and then if I take the gravitational constant right here and multiply it by the mass of the Earth, I get 3.99 times 10 to the 14th. Times 10 to the 14th. And so I take this, I can divide it out, and I multiply it. So the other thing I have to do is multiply this all by radius cubed. Radius is, as we said, 8,900,000. Radius cubed is 7.049 times 10 to the 20th power. So now we have all of this hammered out. We just multiply all that together. And what you're going to get is 697,44096. So 69,744,000. And this is equal to t squared. So we got to take the square root of it. The square root is 8351.293. And so the answer here is this is the time it takes the satellite to orbit, and this is in seconds. It wants to know hours, so we got to divide this by 3,600 to find out how many hours, and the answer for that is 2.319 hours. So it takes just over 2.3 hours roughly for this satellite to orbit the Earth one time. Next thing it asks for is the speed. Okay, so the velocity when something's traveling in a circle is equal to the radius times omega, which is the angular speed. So radius times angular speed, r times omega. And what we got to do here is figure out what omega. We know what r is. What is omega though? So the omega. So this we can break this down. The angular speed is equal to the angular displacement divided by time. And so we know what time is, and we also know what angular displacement is, because in roughly 8,351 seconds, so 8,351 seconds, this thing goes around 1 revolution. So how many radians are in 360 degrees? The answer to that is 2 pi. 2 pi radians in 360 degrees, so 2 pi is our angular displacement. So we know now, we can plug that in the calculator and know that our angular speed is 0.000752 radians per second. And now we got to multiply that, so the velocity is the radius times the angular speed. So we can multiply this by the radius, which we said was 8,900,000, and we get an answer of V equals 6,692.05 meters per second. Well, it wants the answer in kilometers per second, so we just divide this by 1,000, and we get that it's traveling at 6.692 kilometers per second. And the last thing it asks for is the centripetal acceleration. Centripetal acceleration is equal to v squared over r, and so we just gotta we have the velocity already. We said that the velocity is 6,692.05 meters per second. We square that quantity. We divide it by the radius, which was 8,900,000. And the answer, the acceleration, centripetal acceleration, is equal to 5.031857, and that's meters per second squared.